Hello friends, welcome to Best Tutor. This is Rama Vishwanathan. In today's video, we are going to learn about one branch of mathematics which plays a very important role. That is going to be trigonometry. What do you mean by trigonometry? What does it mean? And what does it deal with? Trigonometry. This word is pertaining to triangles, and this word is going to be for measuring, to learn something, right? First of all, we are going to consider basically a right-angled triangle. Before we move on to the basics of trigonometry, I would like to quickly recap what is a right-angled triangle, what are the properties of right-angled triangle. Let us consider a right-angled triangle. A triangle is said to be a right-angled triangle if it has at least one angle equal to 90 degrees. At least one angle equal to 90 degrees. Can a triangle have more than one angle whose measure is equal to 90 degrees? No, it's not possible. And the reason is sum of the angles of a triangle is equal to 180 degrees. So if we have one angle which is equal to 90, whose measure is equal to 90 degrees, then there cannot be another angle whose angle is 90 degrees. Done. So these two angles should be acute angle. That means their measure should be less than 90 degrees. So this is a right angle triangle. This is the 90 degree right angle. Now the side opposite to the greatest angle will have the greatest measure, or it's going to be the longest side of the triangle. We have learnt these in the case of inequalities of triangles, right? The side opposite to 90 degrees, and we have already just now understood that this angle is going to be the greatest angle. So this side is going to be of greatest measure. This is going to be a longest side. This is called as hypotenuse. This side is called as hypotenuse. And the very important property of right angled triangle is Pythagoras theorem. According to Pythagoras theorem, in a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. This is the hypotenuse, and these two are the other two sides. AB and BC are the other two sides, right? We will not learn it as AC square is equal to AB square plus BC square. That is going to be a wrong notion. A triangle, a right angle triangle, can be named by using any other letters. So let us not stick on to AC square is equal to AB square plus BC square. We will learn it as square of the hypotenuse is equal to sum of the squares of the other two sides. Of a right angle triangle. This is possible only in the case of a right angle triangle. So in a right angle triangle, the square of the hypotenuse is equal to sum of the squares of the other two sides. Now, moving on to the basics of trigonometry. Just now we have understood that trigonometry deals with right angle triangles. This is a 90 degrees. A, B, C. Now I am going to consider any one of the remaining two acute angles. An angle can be represented by using a Greek letter called as theta. This is a Greek letter called as theta. I have considered this angle ACB as theta. Now this is the angle under consideration. AC is the hypotenuse, right? The side AB is going to be opposite side to angle C or angle theta. Theta has AB opposite to it, and the side BC is going to be the side adjacent to theta. So AB is going to be the side opposite to theta. The word opposite is a comparative word. It needs a reference. This side is opposite to what? To this angle theta. Similarly, BC is the side adjacent to this is the side adjacent to theta. So in this triangle we have considered a right angle triangle and this angle ACB as theta, which is the angle under consideration. Then AB is the side opposite to angle theta and BC is the side adjacent to angle theta. Now we have 6 basic trigonometrical ratios. So till now we have learned that trigonometry deals with right angle triangles. In particularly we have understood what is Pythagoras theorem and then what are the sides opposite and adjacent to some particular angles under consideration. Now what are the 6 trigonometrical ratios? Trigonometrical ratios. We have sine, cosine, tangent, cotangent, secant and cosecant. These are the 6 trigonometrical ratios. Now what are the basic definitions of these trigonometrical ratios? These words as such are meaningless unless and until they are applied on an angle. Sine is meaningless, sine theta is meaningful, or sine of angle A or sine of some other angle. It makes a meaning, it makes a sense. So similarly we consider a right angled triangle ABC where angle B is 90 degrees. So AC is hypotenuse anyway. Whichever angle is under consideration, AC remains to be the hypotenuse. So this is the angle under consideration, right? So the basic definitions of these 6 trigonometrical ratios on these angles are: sine theta is going to be opposite side by hypotenuse. These are ratios. I am going to consider the ratios of these 3 sides. Here we have 3 sides. One is the side opposite to theta, one is the side adjacent to theta and the other is hypotenuse. So 3 numbers are there. How many possible ratios can be formed? We can form different ratios and for each different ratio I am going to give you a particular name. These are the 6 trigonometrical ratios. If it is opposite side by hypotenuse, I name it as sine theta. Similarly, if it is adjacent side by hypotenuse, I name it as cosine theta. Cosine theta is going to be adjacent side by hypotenuse. Next is tangent of theta. Tangent is going to be opposite side by adjacent side, right? It's going to be opposite side by adjacent side. So we have taken 3 ratios till now. Sine theta is going to be opposite side by hypotenuse. Cosine theta is going to be adjacent side by hypotenuse. Tangent theta is going to be opposite side by adjacent side. If we learn these 3, the remaining 3 ratios will follow directly. How are we going to write down? I am going to explain. But something has to be used to remember these definitions. Won't we get confused? Are we supposed to write opposite side by hypotenuse or adjacent side by hypotenuse? How is it going to be? I will give you a simple mnemonic to remember this. Let us highlight the first letters of all the antecedent and consequent of all the 3 ratios. O, H, A, H, O, A. Let us frame a simple sentence with that. I am going to frame a simple sentence like old Henry and his old aunt. Old Henry and his old aunt. It's a simple sentence. It's very simple for us to remember, right? We can assume that old Henry and his old aunt have gone somewhere to buy something or whatever it is. So I am going to make use of these 6 words. Using these 6 words, this simple sentence will help us to remember all the 3 ratios. And these 3 ratios are going to form the basic of trigonometry, right? We can write down the remaining 3 ratios using these. Old Henry and his old aunt. You ought to remember this order: sine, cosine, tangent. right? There is no option over there. Sine theta, cosine theta, tangent theta. Now moving on to the remaining sine, cosine, tangent, then cotangent. The short form is cot theta. Sine theta, cos theta is going to be the short form. Tangent theta can also be written as tan theta. Cotangent is nothing but cot theta. Then cot theta is nothing but adjacent side. Let me give you the mnemonic and then it will follow. Cotangent theta, then secant theta or sec theta, then cosecant theta or cosec theta. What will be the definitions of this? I will give you the same mnemonic but write it in the reverse order. Old Henry and his old aunt. We have followed this same old sentence in the correct order, then we are going to follow it in upside down order. How is it going to be? Everything is a ratio. Old Henry and his old aunt, right? Old Henry and his old aunt. Similarly, old Henry and his old aunt. Now it's very simple for us to remember that, right? What does A stand for? A stands for adjacent side. Adjacent side. O stands for opposite side. H stands for hypotenuse. A stands for adjacent side, H stands for hypotenuse, O stands for opposite side. Thus, we have learnt all the definitions of the 6 trigonometrical ratios very easily, right? By just remembering one simple statement, old Henry and his old aunt, we have written the definitions of all the 6 trigonometrical ratios. Isn't it simple? Right. So, in this video, we have learnt what is trigonometry, what is a right angle triangle, and we have also learnt about Pythagoras theorem, and then we moved on to the 6 basic trigonometrical ratios, which are sine, cosine, tan, cot, secant and cosecant, right? These are going to be meaningful only when they are applied on an angle. An angle can be theta or angle C or angle B, whatever it is. So there should be some angle over there, otherwise it becomes meaningless. Sine, cosine, tan as such are meaningless. So now we have learnt what are the 6 trigonometrical ratios using a simple mnemonic, and we are going to write down the definitions based on this mnemonic. Once we know the first 3, the remaining 3 is going to be very simple. But we need to remember this order: sine, cosine, tan, cotangent, secant, cosecant. If you observe sine, it's going to be cosine. Just add CO before it. Tangent, next is cotangent. Fifth one is secant. Next is going to be cosecant, which is going to be very simple, right? So in the coming videos, we are going to learn about many more results of trigonometrical ratios, relations between the trigonometrical ratios, and some more things, right? And we are going to learn about trigonometrical identities also. Let's meet in the next video. Thank you.